lagi ngomong.
Okay. Good evening. Today we'll present about aircraft noise. This presentation is made for assignment of sustainable aspect of aerospace engineering environment. This is our name and student identification number. The first is Reza.
My name is Reza Andrianto, 136-18-018.
My name is Fahmi Faisal Habib Budi Wierso, 136-18-115.
My name is Bayudimas Febriansyah, 136-18-121.
So the content of this presentation will be the overview of aircraft noise. It contains causes and impact, and then we will present study case about engine noise on Boeing 787. It contains introduction to Boeing 787, implementation to reduce noise, and output of the improvement. First is about aircraft noise. So, aircraft noise pollution is harmful noise produced by aircraft in flight. The sound production is divided into three categories. First one is from the airframe, the structure of the aircraft, from the airflow around the surface of the aircraft, especially when flying low at high speed. And then second one is from engine noise, the rotation of engine parts, such as fan blades when reaching supersonic speeds. Those one is airframe noise. There are some components that make noise from airframe noise, such as landing gear, flaps, slats, lift and control surface, spoilers and speed brakes, and then Kruger flaps. This one is the summary of noise from airframe noise, the source, generating mechanism, parameters, conditions, and then the theoretical understanding. This table is referred from a journal. And then engine noise. There are some components such as fan, jet, combustion, turbine, and compressor. And then this one is the summary of engine noise, the source, generating mechanism, parameters, condition, and theoretical understanding. This table is also referred from a journal.
So next is the impact of engine noise. So aircraft engines are the major source of noise and can exceed 140 decibels during takeoff. While airborne, the main source of noise are the engines and the high turbulence over the fuselage. So there are health consequences of elevated sound levels that is coming from an airplane. Elevated workplace or other noise can cause hearing impairment, hypertension, ischemic heart disease, annoyance, sleep disturbance, and decreased school performance. Elevated noise levels can also create stress, increase workplace accident rates, and stimulate aggression and other antisocial behaviors. An aircraft that is too loud can also face criticism from the public. One notable example is how the Concorde had complaints for its noise during low altitude flight and its sonic boom. So this is an image of the Boeing 787 engine. You can see that on the engine, there is this chevrons that is used to reduce engine noise. So the Boeing 787 Dreamliner is a long-haul, wide-body, twin-engine jetliner, which features lightweight construction. The aircraft is 80% composite by volume, and Boeing lists its materials by weight as 50% composite, 20% aluminum, 15% titanium, 10% steel, and 5% others. Aluminum has been used throughout the wing and tail leading edges. Titanium is predominantly present within the elements of the engines and fasteners, while various individual components are composed of steel.
Okay, so the next one is the problems on reducing noise. Engines will be made quieter by simple solution of adding a muffler. Muffler, or sometimes we can say it like a silencer, and the muffler works briefly like when the sound wave is produced by the engine, the muffler will counter the sound wave, and that counter will make a negative of the sound wave produced by the engine earlier, and that the counter sound wave will cancel out the sound wave from the engine, and that's how the muffler works, and that's why the muffler can reduce the noise that coming from the engine. They are available for many models and can be installed at an astronomically cost. The parts and labor are actually pretty cheap. It is the certification cost that makes it sting so badly. It costs a lot of money to develop a certified parts for airplanes, and mufflers are mandatory. And because they are so expensive to install, most don't because the costs outweigh the benefits. It costs far less to buy a decent active noise reduction headset instead. These are some implementation that has been going on the Boeing 787. The first one is it uses modern high bypass turbofan engine, which are quieter than older turbojets and low bypass turbofans. And the second one, the air inlet containing sound absorbing material, so this could also reduce the sound from the engines. And the third one, the exhaust duct covered with a chevron tooth pattern from the rim, which combine hot and cold airflow more efficiently to reduce the engine noise. This is what the engine of the Boeing 787 looks like that from the earlier picture. The next one is improved aerodynamics that reduce airframe noise. And the last one is the composite material that is used on the fuselage now contains elastomeric insulators that could reduce the cabin noise. And from this presentation, we can summarize the output of the improvement. So the first one, according to the Boeing, the 787 prevents sounds above 85 decibels from leaving airport boundaries. Boeing also claims that the noise footprint of the 787 is 60% smaller than those of today's similar sized airplanes. Like what my friends have said, that the sound, if it's reached above 85, it could damage our hearing, and that can cause us in hearing loss. So this is why the reducing noise is very important. The second one, a study conducted by the London Heathrow Airport has shown that during the flight, the first 17 months of its operation, Boeing 787 is significantly quieter than the 767 and A330. The 787 is on average up to 7 decibels quieter on the departure than the 767, and up to 8 decibels quieter than the A330 aircraft. The result also confirmed that the 787 is up to 3 decibels quieter on arrival than the aircraft types it is intended to replace. And the last one, it reduced cabin noise according to the passengers. And these are the differences that we look for making this presentation, and this is the end of our presentation. Thank you for listening.
Thank you.
Thank you for watching.